Hi, our next stop in solving problems involve using equations. When we use equations, in many cases, we're dealing with variables that we are given and we're solving for one unknown. What's important in these problems are units. The example that we're going to focus on is the ideal gas equation. PV is equal to nRT. We'll learn more about this equation in chapter 10, but we should be able to solve a problem in which we're given four variables and we're solving for one that we don't know. And that's the case that we're going to do in this example. Now, the ideal gas equation, P is pressure, and its units will depend upon the value of R. V is volume, and it depends upon the value of R. N is the number of particles, and again, depends upon the value of R. And T is our temperature. Now, what's important about this problem, as I said, the units really do depend upon what this value of R is. So let's go through this example and understand how we have to look at our units when we're solving problems involving equations. So in this example, the problem that I have posted is we're given the ideal gas equation, PV is equal to nRT. And the question is, what volume, so we want to solve for V, what volume would be occupied by 1 mole, that's our value of N. P is our pressure, 1.10 atm is a unit of atmosphere. T is our temperature, 25 degrees Celsius. And this is our constant. This is a value that we just plug in here, and it's given to us in tables or in our book. It's 0.08206. And the units of our constant are really important. The units that we're going to be able to convert to have to be in liter, atmosphere, Kelvin, mole. So our volume is going to be in liters that we're solving for. The pressure is atm, and we have that. That's good. The number of particles is mole, and that's in the denominator. We're good. Temperature has to be in Kelvin. We have Celsius. So as a first step, when we're solving this problem, before we go any further, we need to convert our temperature to Kelvin. And we do that, as you recall, by adding 273.15. And our temperature is going to be 298.15 Kelvin. So those are all of our variables. Now all we're going to do is rearrange our ideal gas equation and solve for V. If we do a little bit of algebra, volume is equal to nRT divided by P. And now we can plug in all of our values for N, R, T, and P and solve this equation and make sure that we recognize that the units cancel out. N is the number of moles. We have 1 mole. Our value of R, 0.08206. I'm going to write this a little down here, a little further. We're solving for V. N is the number of moles. R is our gas constant. T is our temperature that we've converted into Kelvin. P is our pressure, 1.10 atm. So remember, this is N, R, T, and that's P. Good? Let's look at our units. Moles cancel out. Kelvin cancel out. ATM cancel out. We're going to get an answer of volume in liters. And in this case, we're gonna round it to 3 significant figures. The volume that I've calculated in this problem, 22.2 liters. Limiting myself to 3 significant figures, that's because the value for N and the value for P only have 3 significant figures, our temperature. is 25 degrees Celsius, and that actually only has 3 significant figures also. So that's how we use equations. We carefully look at our units and make sure everything is compatible when we use a constant such as R.